7.3 Pressure and Volume, Boyle's Law. Chapter 7 Gases. 7.3 Pressure and Volume, Boyle's Law. Boyle's law states that the pressure of a gas is inversely related to its volume when T and N are constant. If the pressure, P, increases, then the volume, V, decreases. 2. PV constant and Boyle's law. The product Pxv is constant as long as T and N do not change. P1V1 equals 8.0 atmospheres by 2.0 liters equals 16 atmospheres length. P2V2 equals 4.0 atmospheres by 4.0 liters equals 16 atmospheres length. P3V3 equals 2.0 atmospheres by 8.0 liters equals 16 atmospheres length. Boyle's law can be stated as P1V1 equals P2V2, T, and constant. Solving for a gas law factor. The equation for Boyle's law can be rearranged to solve for any factor. P1V1 equals P2V2 Boyle's law. To solve for V2, divide both sides by P2. P1V1 equals P2V2. P2 V1x P1 equals V2. P2. Boyle's law and breathing, inhalation. During inhalation, the lungs expand. The pressure in the lungs decreases. Air flows towards the lower pressure in the lungs. Boyle's law and breathing, exhalation. During exhalation, lung volume decreases. Pressure within the lungs increases. Air flows from the higher pressure in the lungs to the outside. Guide to calculations with gas laws. Calculation with Boyle's law. Freon 12, CCl2F2, is used in refrigeration systems. What is the new volume, L, of an 8.0 liters sample of freon gas after its pressure is changed from 550 mm of mercury, to 2200 mm of mercury at constant T? Step 1 Set up a data table. Conditions 1 Conditions 2 No Predict. P1 equals 550 mm of mercury. P2 equals 2200 mm of mercury. P increases. V1 equals 8.0 liters. V2 equals? V decreases. Calculation with Boyle's law, continued. Step 2 Solve Boyle's law for V2. When pressure increases, volume decreases. P1V1 equals P2V2. V2 equals V1x B1. P2. Step 3 Setup problem. V2 equals 8.0 liters by 550 mm of mercury equals 2.0 liters. 2200 mm of mercury. Pressure ratio decreases volume. Learning check. For a cylinder containing helium gas, indicate if cylinder A or cylinder B represents the new volume for the following changes. N and T are constant. 1. Pressure decreases. 2. Pressure increases. Solution. For a cylinder containing helium gas, indicate if cylinder A or cylinder B represents the new volume for the following changes. N and T are constant. 1. Pressure decreases, cylinder B. 2. Pressure increases, cylinder A. Learning check. If a sample of helium gas has a volume of 120 milliliters, and a pressure of 850 mm of mercury, what is the new volume if the pressure is changed to 425 mm of mercury? 160 milliliters to 120 milliliters 240 milliliters. Solution Conditions 1 Conditions 2 No Predict. 240 milliliters. Conditions 1 Conditions 2 No Predict. P1 equals 850 mm of mercury. P2 equals 425 mm of mercury. P decreases. V1 equals 120 milliliters. V2 equals? V increases. V2 equals V1 x P1 equals 120 milliliters by 850 millimeters of mercury equals 240 milliliters. P2 425 millimeters of mercury. Pressure ratio increases volume. Learning check. A sample of helium gas in a balloon has a volume of 10 L at a pressure of 0.90 atmospheres. At 1.40 atmospheres, T constant, is the new volume represented by A, B, or C. Solution. A sample of helium gas in a balloon has a volume of 10 L at a pressure of 0.90 atmospheres. At a higher pressure, T constant, the new volume is represented by the smaller balloon. Learning check. A 3.2 liters B 6.4 liters C 12.8 liters. If the sample of helium gas has a volume of 6.4 liters at a pressure of 0.70 atmospheres, what is the new volume when the pressure is increased to 1.40 atmospheres, T constant? A 3.2 liters B 6.4 liters C 12.8 liters. Solution. Step 1. Set up data table, conditions. A 3.2 liters. Step 1. Set up data table, conditions. Conditions 1. Conditions 2. No. Predict. P1 equals 0.70 atmospheres. P2 equals 1.40 atmospheres. P increases. V1 equals 6.4 liters. V2 equals? V decreases. Step 2. Solve for Boyle's law for V2. V2 equals V1 x B1. P2. Step 3. Setup problem. V2 equals 6.4 liters by 0.70 atmospheres equals 3.2 liters. 1.40 atmospheres. Volume decreases when there is an increase in the pressure. Temperature is constant. Learning check. D and N constant. 1 200 millimeters of mercury. 2 400 millimeters of mercury. 3 1200 millimeters of mercury. A sample of oxygen gas has a volume of 12.0 liters at 600 millimeters of mercury. What is the new pressure when the volume changes to 36.0 liters? T and N constant. 1 200 millimeters of mercury. 2 400 millimeters of mercury. 3 1200 millimeters of mercury.